Hello and welcome to Enhancing Observability of Distributed Applications on AWS. My name is Mustafa Safipur, an Enterprise Solution Architect, and in this talk we're going to show you how you can use AWS Observability Services to improve your application's performance and reliability. Let me begin with this story and first introduce you to our antagonist, a loading spinner. Imagine this set, a late evening at any company pet friends. A group of people, seemingly excited, are busy at their desks and around large dashboard screens. The excitement is for the launch of their new pet adoption service, which is going live tonight. Jane, our DevOps engineer, is about to promote a staging environment into production and make it happen. Eventually the time comes, and Richard, our first customer, is on the application trying to find and adopt his favorite puppy. Everything is perfect, that is, until he gets to the final stage of paying for the adoption. This is where our antagonist jumps into the scene and starts spinning, creating chaos and confusion. At this stage, as you can imagine, none of our human characters are happy. Most of all, our protagonist, Jane, and the technical team is under enormous pressure to quickly identify the root cause and resolve the issue. Fast forward, a couple of days later, the team review the event and start listing what went wrong and why it took so long to resolve it. They grouped the issues into three main categories. The main obvious problem was that it took them a long time to detect the issue and then identify the root cause. Some of this was due to the fact that not all microservices supporting this customer journey had observability implemented consistently. These microservices were implemented using different technology stacks and in different AWS accounts by different teams, so some of them did not have sufficient levels of logging, metrics, or traces. As for the others, whilst the data was collected, but formats and naming conventions were not consistent. The other group of problems they summarized as insights challenges. Even when the application had fairly consistent observability coverage, they did not have the right tools to be able to correlate logs, metrics, and traces. So they were unable to quickly gain insights into problem root causes. Now, if we zoom out of our story, there is a lot more that teams expect from observability platforms these days. We hear from our customer DevOps teams that they need a cost-effective way to analyze and model trends and correlate issues, and also understand the real-world user experience across their applications. At the same time, development teams like to gain deeper insights into how their applications function in the real world and build highly resilient applications that automatically heal when issues occur. Before we dive deeper into the how section of this talk, let's get a quick overview of AWS Observability Services. AWS offers a range of native, open source, and partner observability solutions to help our customers choose the right tool for the job. With the native option, Amazon CloudWatch is the foundational service. Combined with AWS X-Ray, it provides you with capabilities across all areas of infrastructure, application, and synthetic monitoring. So let's start from the bottom layer of this stack. Instrumentation is to collect logs, metrics, and traces from infrastructure and applications. For infrastructure monitoring, a lot of AWS services like Amazon API Gateway, AWS Lambda, Amazon RDS, and many more publish logs and metrics into CloudWatch. We call these vendor logs and metrics, available to you out of the box. On top of this, you can use CloudWatch Agent and SDKs to collect logs and metrics from various compute environments on AWS or on premises. Then with X-Ray, you instrument your application code using X-Ray SDK, and X-Ray provides an end-to-end view of requests as they travel through your application, and shows a map of your application's underlying component. In the next layer, we have Container Insights and Lambda Insights. Both services simplify the collection and aggregation of curated metrics and logs from AWS Lambda functions and containers respectively. Then there is CloudWatch Synthetics, which allows you to continually monitor your application endpoints and verify the customer experience even when you don't have any customer traffic on your applications. This enables you to discover issues before your customers do and reduce that time to detect. Finally, in the top layer, Amazon CloudWatch Service Lens brings together CloudWatch metrics, logs, and traces from AWS X-Ray to give you a complete view of your applications and their dependencies. Service Lens, as you would see in a demo shortly, gives you that single observation point to visualize your application end-to-end and analyze data to quickly pinpoint root causes. Beyond AWS native services, many of our customers have preference for open source or AWS partner solutions. So let's have a quick look at the stack again. Instrumentation is key in solving the consistency challenge we discussed before. You can use AWS Distro for OpenTelemetry to instrument your application just once and send correlated metrics and traces to multiple AWS and partner monitoring solutions. Also, if you're using containerized applications and already using popular open source tools like Prometheus and Grafana, we offer secure production-ready, fully managed service for both of them on AWS. Finally, there is a vast ecosystem of technology partners who provide observability solutions hosted on and integrated with the AWS cloud. If you're looking for a partner solution, be sure to check out our AWS partner portal. With that overview, let's change gear a little bit and see how we can get started. We know to make your application observable, you need to collect data in three main pillars of logs, metrics, and traces. So it all starts with instrumentation. We have two paths you can take here. The two paths are CloudWatch Application Insights and Do-It-Yourself approach. Application Insights is a great way to get started really quickly. It takes away the initial heavy lifting by recommending key metrics, logs, and other data sources to monitor for your application. In this talk, we're focusing more on the do-it-yourself approach, but if you're interested in the first approach, please check out our follow-up resources slide at the end of the talk. Beyond what Application Insights offers you, the other option is doing it yourself. Keeping in mind the three pillars with observability are logs, metrics, and traces, let's start with logs. There are several different ways to get logs from your application. You can use CloudWatch Agent and configure it to pick up logs from various locations and send them through to the CloudWatch Logs API. For containers, there is FileLens and AWS Logs Log Driver, which route logs to CloudWatch. You can also implement a logging package in your application and configure it to send logs to CloudWatch. These top three options are all abstractions of the PutLog event API, which can also be used directly. When it comes to metrics collection, there are also multiple options. On top of the PutMetric data API call to send metrics directly through to CloudWatch, there are several abstractions. Similar to logs, the first abstraction is CloudWatch Agent, which can be installed along with your application. CloudWatch Agent collect metrics and send them to CloudWatch APIs for you. The next option is AWS Distro for OpenTelemetry. We discussed OpenTelemetry earlier, but the key to highlight here is that it gives you flexibility of choice when it comes to observability platforms without the need to refactoring your instrumentation. Last option is embedded metric format, which is an approach of sending your metric data in the form of structured log events. CloudWatch picks up the log event as a metric because it arrives in the embedded metric format. This is a great approach for product-level metrics. Now let's talk trace collection. The X-Ray SDK and AWS Distro for OpenTelemetry are abstractions over the PutTrace segments API call. They can be used to capture telemetry data at the edges of an application or service, such as an inbound request, outbound HTTP call, database call, and so on. X-Ray SDK and AWS Distro for OpenTelemetry are very similar models. Both have auto-instrumenting for .NET and Java, which means the auto-instrument agent does the bulk of heavy lifting, with the alternative being manual instrumentation, where you import a tracing package into your application. So now let's take a quick look at the architecture of how the AWS Distro for OpenTelemetry works. So you're running your application on some form of compute on AWS or in fact on premises. In this example, we assume it's running on Amazon ECS. Firstly, you import AWS Distro for OpenTelemetry package into your code. This will send metrics and traces to OpenTelemetry collector, which in turn publishes data to your monitoring platforms such as CloudWatch or X-Ray. The collector handles receiving, processing, and exporting telemetry data using open source formats and is able to send it to multiple monitoring platforms. So far, we looked at ways to collect relevant data across your application microservices. In reality, it is common that different microservices or applications of the same portfolio run across different AWS accounts and potentially even different AWS regions. So to have a central view of all of your microservices or relevant applications, it is common to introduce a monitoring account. You can then use cross-account, cross-region feature of CloudWatch to create a high-level dashboard view of your entire application, including metrics, log widgets, and alarms into the central monitoring account. From the central monitoring dashboard, you can also drill down into account-specific dashboards without having to sign in and out of accounts or switching regions. The other useful pattern is to configure the collectors like AWS Distro for OpenTelemetry, CloudWatch Agent or X-Ray Agent to directly publish application logs, metrics, and traces across account to the monitoring account. If you'd like to learn more about cross-account sharing feature of CloudWatch, other useful patterns, and how you can implement them, please check out our follow-up resources slide at the end of the talk. With that, let's hand over to Abhay to dive deeper into a demo.
Hi, my name's Abhay Chauhan, and I'm a solution architect here at AWS. Let's switch gears slightly and dive a bit deeper into an example. Here we're going to look at the pet adoption store. The store has been built using several microservices, 5 in this case. The first 3, pet search, pay for adoption, pet list adoptions, are built using ECS Fargate. The next, pet site, is running on Kubernetes EKS on EC2. And the last one, pet adoption status, is built using Lambda functions. Being microservices, we have various databases being leveraged behind the scenes, such as Amazon Aurora, such as a relational database, DynamoDB as the key value store, and Amazon S3 for our object storage. The key to note here is that we have a distributed system, various technologies at every layer. Now let's switch over the code for this platform to see how we can approach instrumenting one of these microservices. Here we have a pet adoption solution. This is an open source Git part repository, so we'll provide you a link at the end so you can play around with it. Each of these folders is a separate microservice in our application. Let's take a look at the Pay for Adoptions microservice to see how it's been instrumented. As you can see, this is a .NET solution, but don't worry if you haven't worked with .NET before, but I want to give you an example of how easy it is to instrument your code to send traces. This is our project file, which includes all the packages we've been using in this microservice. To get started, we imported a few packages such as AWS SDK X-Ray on line 12, which is a low-level API to work with X-Ray, and additional .NET packages from line 13 to 16, which plugs into various parts of the framework to give us detailed tracing information. I'll show you how these packages are used in our code now. So let's switch over to the startup file. This is where we configure our application on startup. On line 34, you can see app.useXray method call, which is asking X-Ray to start tracing our inbound requests. We are also giving this microservice a name, Pay for Adoption, as the first parameter. This is the name our observability platform will give to our microservice. This is all the instrumentation code you need to get tracing working on your incoming requests. Now let's take a look at our application code to capture more tracing. So opening up Home Controller, this is the code that handles inbound requests. On line 24, we're using HTTP client object. This is used to send outbound HTTP requests in .NET. We're instrumenting this HTTP client object with the X-Ray tracing handler, which enables us to capture tracing information such as where the requests are going and the timings around that request. On line 31, we're registering X-Ray with AWS SDK. So when our application makes a call to any AWS service using the AWS SDK, we'll capture traces for those calls as well. So at this point, we're tracing our inbound requests, outbound requests, and calls to AWS services. Now let's take a look at the complete adoption method. This is the code that runs to adopt a pet. You can see on line 45, we're simply executing a database query, an insert SQL statement in this case. On line 51, we're using the traceable SQL command wrapper, which is a wrapper around the standard .NET SQL command object to execute the database query. This allows us to capture tracing information for the database command, such as the database and the timings around that query. If you're using an ORM, it's just as easy to instrument tracing for those as well. On line 47 is where we're adding metadata to the trace, capturing the query that will be running on the database. This is wrapped in a big try-catch block, so any exceptions or errors that occur will be caught on line 58, and we'll have that error information available on our trace too. So taking a step back, we've just learnt how we can instrument a codebase to capture inbound, outbound requests, as well as AWS service calls and database queries. The key operations at the edge of our service, which gives us more information to work with in CloudWatch and X-Ray. It would be a very similar approach for OpenTelemetry. We'd simply use different packages. Now let's head back to the management console. First, I'm going to take you to Elastic Container Service, ECS, to see how the code base we just walked through is running, pay for adoption. In addition to instrumenting the code, another key part of the instrumentation is also the sidecars, which are containers supporting the application. We can see here we've got 3 containers running for pay for adoption task. We've got an application code running in our container. We also have FileLens router here. FileLens is being used to process and route our logs from our application container to CloudWatch logs. The same with traces. We've got X-Ray daemon running as a sidecar. And so this offloads the application container with the responsibility of processing and pushing all those logs and traces to the sidecars, X-Ray daemon and FileLens. So let's head over to CloudWatch now, and in CloudWatch I want to show you Service Lens Map. Service Lens Map is a feature of CloudWatch which gives us a high-level view of the logical components in our architecture, based off the 3 pillars, logs, metrics, and traces that we're collecting from our application. So as an example, we can see pet search microservice, pet site, pet adoptions as an example. We've also got a range of other nodes such as AWS Services and the connections to them. Over in the legend and options, if I switch on the metrics, you can see that there's live traffic on this system. So for example, if I zoom in on the pet search node, we have just under 160 requests per minute. And we have an average latency of 15 seconds, which isn't great. Now I want to draw your attention over to this partial red outline on some of the nodes here, which indicates a server fault. Let's start with looking into these components to see what's going on with our system to cause this. Let's start with pet site, which is the front page of our application. We're going to filter the traces just to the ones with faults, and then click on Analyze Traces, which takes us over to the X-Ray console. I'm going to scroll down. We can see aggregations to help us work with these traces. Here we can see over 50% of the issues are based on the pet list adoptions URL. That's quite sizable. So let's filter in on that by clicking on it and then drill into the first trace based on that filter. We can see it's a GET request with a 500 HTTP response code, which is what we're looking for. Here in the trace map, we can see there's a few pieces of the puzzle. Pet site is calling pet list adoptions, which is then calling pet search. It seems like there's a bunch of faults happening in pet search, with the red line indicating, and other nodes part of the trace as well, such as DynamoDB at the bottom, S3, and the Postgres database. So this is a relatively complex trace. So scrolling down in the pet site trace, we can see we're calling pet list adoptions. So clicking on that and heading over to the exceptions tab, we can see we're getting 504 HTTP status code, a gateway timeout. So the request is timing out, waiting for a response. Now this is a symptom and not the root cause, so we need to drill a bit further. Closing that, let's scroll down the traces further. I'm just trying to skim these icons, looking for a red icon rather than the green to see where the next issue is. So the next red fault seems to be on a line with DynamoDB. It seems that DynamoDB has a duration of 1.4 minutes, which is very slow for DynamoDB. Clicking on this error, jumping to the exceptions tab, we can see the error message as the level of configured provision throughput for this table was exceeded. It seems that DynamoDB was throttling our requests. But what I want to highlight here is that we can drill from a high-level architecture and find exceptions which are causing errors and slowing our system down, which speeds up our ability to detect and identify these issues. We aren't going to fix this throttling issue as that's not the focus here, but let's head back to the trace to see if there's any other faults happening. Scrolling a bit further down for a red icon, we can see a similar DynamoDB issue, but let's skip that. And the next one we've got is in pet search. We've got an issue with S3. So let's click on that and head over to the exceptions tab. We can see an access denied message coming back. So it seems to be calling S3, but S3 is responding with access denied. So there's something that we've got to debug. The best way to do this is to jump into code. So let's scan our stack trace here at the bottom to see the last touch point in our code base. And we can see it's the search controller.java on line 85. So let's head over to our code and open up search controller to see what we can find. Opening up search controller.java from the pet search microservice and heading down to line 85, we can see the S3 client is trying to create a bucket. We're looking to create a bucket at this point, but we don't have permissions to do so. This could be bad code or bad permissions, but either way, I'm looking to demonstrate that even though we have a bug or a random issue that occurs in our code, as long as we're radiating our logs, metrics, and traces to CloudWatch and X-Ray, it gives us the ability to drill down and find issues very quickly. So coming back to summarize what we've learned in this demo. We started looking at how we've instrumented pay-for-adoption's microservice using tracing and how we used sidecuts to transmit those logs and traces to CloudWatch logs and X-Ray. Once we had data being shared with CloudWatch and X-Ray, this enabled the platform to aggregate this data and give us a high-level view of our entire system in real time. We're able to see errors and latency issues bubble up to the top in ServiceLens map, which speeds up our ability to detect and drill down through the lines of code to identify the issue. Now that we have a better understanding of observability and its implementation, let's talk about some of the best practices we've seen around in the industry. Firstly, the key to successful observability platforms is understanding that it needs continuous improvement and investment. This means alarms, dashboards, metrics, custom annotations, anything that can help you know what's going on in the application. If you notice there's too much noise in the logs, remove them. If you see unused metrics, get rid of them. Fine-tune those dashboards so they quickly tell you what you need to know. First implementations are rarely right, so iterate on them and nurture them. And the same goes for people. Have observability champions. These are people who are passionate about observability and will keep learning best practices and teach their colleagues too. Support them, help them learn. Observability champions, when injected into a team, can uplift a team's capabilities very quickly. And understand the difference between symptoms and root causes. We constantly see customers who implement observability but don't invest in it, suffer from alarm fatigue when you trigger too many useless alarms, which causes people to ignore those alarms. A great practice in this space is to focus on symptoms rather than root causes. Sounds unusual, but let me give you an example. A root cause might be high CPU on your nodes, but the symptom would be increasing error pages for your users. Alerts should be focused on those symptoms, the number of error pages, as it's tightly correlated to the user experience. Easy onboarding is incredibly important as we embrace distributed applications. We need to make sure of two key aspects. It's easy to consistently implement observability in new components and services, pre-configure those alarms to the right channels, generate dashboards based on the resources provisioned. Easy onboarding for team members too. Ensure that they're formally introduced and comfortable with the observability platform. Run boot camps for the new starters. People learn when they get their hands dirty. Show them what good looks like and enable them to create dashboards, metrics, and capture the traces needed. No one wants to support a system that doesn't have great observability. Those outages will be very stressful events. So let's recap. A key driver behind the evolution of observability is the fact that organizations and technology teams are more based on their decisions in data. This means we use 3 pillars: logs, metrics, and traces to gain insights and resolve issues quickly. Specifically, we talked about the lack of consistency as a challenge in making our applications observable and how AWS Distro for OpenTelemetry helps you instrument and once achieve that consistency with metrics and traces. Also, how CloudWatch automatic integration with many AWS services helps bring consistency in coverage to all your application components from an observability standpoint. So once we have consistent types and levels of data for those components in the application available, we saw how CloudWatch Service Lens along with CloudWatch Insights helps you correlate signals and gain insights to your application performance. And ultimately, how both of these measures and tools help bring down time to identify and resolve the issues. Finally, we touched on some of the best practices we know. The key to success for the observability mission in your organization is not only the tools and services, but rather how you use them and organize your tools and processes around business demand and outcomes. Here are some additional resources if you're interested in diving deeper on any of the topics we've discussed. And to continue your cloud journey, please use these training resources. That's all we have for you today. We really value your feedback to help us improve these sessions. So please complete the survey, and from myself and Mustafa, thank you for watching.